Good morning. I am Dr. Fatima. Today I am taking electrical parameters of operational amplifier. Electrical parameters are common mode rejection ratio, common mode input voltage, input offset voltage, input bias current, input impedance, input offset current, output impedance, slew rate. Common mode rejection ratio is actually the ability of an amplifier to reject the common mode signals or unwanted or noise signals while amplifying the difference of the input signal or differential signal. Common mode rejection ratio is denoted by CMRR. And this is a ratio of open loop gain AOL to the common mode gain ACM. This common mode rejection ratio is generally written in dB. So this is equal to 20 log of AOL divided by ACM. Higher the common mode rejection ratio, the better will be the operational amplifier. Generally, this CMRR is expressed in dB and it is decreases with frequency. Higher the value of CMRR, more noise will be rejected. Next electrical parameter is input offset voltage. Ideally, the output of an amplifier must be 0 volt if the input is given 0 volt. But if input is not given, there will be some output present at the output of the operational amplifier. This is called output offset voltage. So to make this output offset voltage or output voltage equal to 0 or null, a small DC voltage is given at the input. Like here, the VB1 and VB2, these two inputs are given, these two DC inputs are given to the op-amp, and the value of these two DC inputs are equal to make this output null. So this VB1 and VB2 are called input offset voltages. This is generally this is in the range between 2 millivolt or less than this. So thus the differential DC voltage is required between the inputs to force the output to 0. This is called input offset voltage. That given DC voltages to make the output null is called input offset voltages. Next is input offset current. Since here the two DC voltages are connected, because of this current start flowing I1 and I2. So the difference of these two current is called input offset current. Input bias current, because of presence of input offset voltages like here V1 and V2, two currents are flowing I1 and I2. The average of this I1 and I2, this is called input bias current. Ideally it should be 0, but since presence of V1 and V2, so bias I1 and I2 are present, because of this bias current is also present. It is the average of both input currents. Input impedance, this is the total resistance between the inverting and non-inverting input terminals. Differential input impedance is the total resistance between inverting terminal, this is the inverting terminal, and non-inverting terminals. Common mode input impedance is the total resistance between each input and ground, between this input and ground and this input and ground. Next one is slew rate. This is the maximum rate of change of output voltage with respect to time. This is called slew rate. Here, this is the ratio of maximum rate of change of output voltage with respect to time. The significance of slew rate is that this is showing the speed of the speed of the output availability on op-amp. As soon as the input is given, the output must be available. If it is so, then slew rate will be infinite. But practically, this is not possible. The output takes some time to reach to the input value. So the higher the value of slew rate is desirable. Thank you. This completes this lecture.